All right, this is unit number 3, video number 5, orbital diagrams. One of the things we want to do is represent all of the quantum numbers in our representations. Up to this point, we've been doing 1s2, 2s2. That represents n and l. N equals 2, l equals 0 is a 2s. But it doesn't tell us the breakdown of those electrons inside. And that breakdown is important. So, what we want to do, if we take an element like oxygen, oxygen has 8 electrons in the ground state neutral atom. So oxygen is going to be 1s2, 2s2, 2p4. Well, we've got the n quantum number, the l quantum number, but we don't have any representation here. So what we do a lot of times is draw out the orbitals. These are the actual orbitals. So our first shell-subshell combination, second shell-subshell combination, third shell-subshell combination. Obviously, shell and subshell can be energy level and sublevel. In the 1s, we have 2 electrons. The first electron is going to be spin up, or plus 1/2. The second is going to be spin down. 2s, spin up, spin down. Now the 2p has 4 electrons. Hund's rule tells us electrons enter equal energy orbitals with parallel spins. So these 3 orbitals are equal energy. We know in the imps of L values they're plus 1, 0, minus 1, or actually minus 1, 0, plus 1. But a lot of times we represent them as px, py, pz, because those orbitals are literally sitting along the axis, x, y, and z. But our 4 electrons are going to go in, spin up, spin up, spin up. So no spin downs until every orbital that's equal in energy has an electron, then we're going to go spin down. Now, if we take a larger atom, we're probably going to represent only the valence electrons as an orbital diagram. We don't want to do something like lead and have to have, 82 spin ups and spin downs when the core is really having totally shut down and has no effect on the chemistry. So let's do an element like arsenic. Arsenic is number 33 on the periodic table. It's an atomic number of 33. So it has 33 electrons in the neutral atom's ground state. The noble gas inside of arsenic is argon. So argon is going to be that noble gas. It's a 4th row element, so we're going to have 4s2, 3d10, 4p3. This is what we want to draw out in our orbital diagram. So the 4s here, 3d, the d has 5 orbitals. And then the p, 3 orbitals. 4p. The 4s has 2 electrons, spin up, spin down. The d has 10 electrons, is completed, but let's go ahead and do it in Hund's rule order. There's our 5 spin ups. Now we're going to go with 5 spin downs. Now the 4p has 3 electrons, spin up, spin up, spin up. So an orbital diagram is going to give us a way to represent all the quantum numbers in one complete unit.